The last thing we need to talk about with functions is the transformations of functions, how these functions can change, how they can move. So we're going to start with a generic parent function, f of x. This can be any function. It could be an absolute value, it could be a power, it could be a quadratic, it could be any function. This works for any function. But we're going to make some changes to it and call it g of x. So notice f of x is sitting right in here. Here is the parent function, but we have done a whole lot of things to it, and we need to figure out what those things do. So I'm going to start with the shifts. There are two shifts we talk about. There's a vertical shift and a horizontal shift. A vertical shift is an up and down. So if we have a plus number on the outside, it moves it up. If we have a minus number, it moves it down. Plus 7 moves it up 7. Minus 2 moves it down 2. That's the outside number. Now, if we have a number on the inside of the parentheses, now we're looking at what's called a horizontal shift. Now, we have to remember that parentheses can be an absolute value. It could be a fraction bar. They work like parentheses, or it can be actual parentheses. So this particular parenthesis is going to tell me the horizontal shift. Now, here's what's confusing about it. It's in parentheses. It's actually backwards. So if I have a negative number, it's going to move it to the right. If I have a positive number, it's going to move it to the left. It's backwards of what you would think, like the vertical shift. Positive for vertical moved up, negative moved down. Inside the parenthesis, it's backwards. Positives move left, negatives move it to the right. There's two more transformations that we do. These just move it around. There's two out front that do some other things. Let's start with the sign in front. Normally we have a positive sign out front. But if we put a negative sign out front, we do a reflection over the x-axis. We mirror this. If a function was pointing up, now it's pointing down. If it was pointing down, now it's pointing up. So we reflect it over the x-axis. That's the sign that's out in front. When we talk about the value out front, this does something a little different. This does what's called a vertical stretch or a vertical compress. So we need to look at the value of a. We just look at the a. We don't care about the sign in front. So I'm going to put an absolute value in front of this because we don't care about the sign, just the actual number. So if that number that's sitting in front of the original function is bigger than 1, it is a stretch. Think of when you grab a hold of a picture and pull on it, it gets longer. People in the picture get taller. Things get stretched out. That's when you see a number bigger than 1. If you have a number smaller than 1 but still above 0, think of your fractions. Think of a half. Think of 0.25. Things that are between 0 and 1. Now we have what's called a vertical compression. This thing has been squished. And when you squish a photo, people in the photo tend to get bigger. They get compressed and they have to fall out a little bit. So that's what's called a vertical compression. That's the number that's in front. So just to show you an example of a typical function we may see. Here is a quadratic function. This is the parent. Nothing has changed with this. We know what it looks like. We can put this into our graph. So now I'm going to make some changes to that. The parent function is still sitting here, x squared. It's right here. But they have done a few things to it. Out on the outside, they have moved this up 4 places. It has been vertically shifted up 4. In this parenthesis, they have done a horizontal shift. They have actually moved it left 3. Remember, things in parentheses are backwards. The sign in front is telling me this has been reflected. So instead of this quadratic pointing up, it is now pointing down. That negative tells me my quadratic has been reflected. And the number here is definitely smaller than 1, so we're looking at a compression. A vertical compression. So this thing has been squished. So if it's a nice U-shaped, it might be a fatter U now. Again, these things work with any function, any type of function, any parent, absolute values, quadratics, cubics, lines, they all work. These things affect them all the same. So that's the last thing we're going to talk about as far as transforming our function. So now that we've done these transformations, let's take a look at one of the things that we tend to do with our polynomials. We've talked about higher order polynomials, quartics, fifth power, sixth powers. We've talked about finding answers, but now let's go back to when they give us the answers. Okay, we've done this before. They gave us some answers here. We turn them back into factors. And we FOIL these out. So we're going to multiply these out. So I get x squared minus 14x plus 45. But take a look at what they say in the directions. They want me to find a quartic functions with only two real answers. So a quartic is a fourth degree, but it only has two real answers, so I have to do something for those other two answers because I'm not at a quartic yet. So what we're going to do is we're going to take the easiest non-real answers. Okay? The easiest way to do that is an x squared plus 1. Okay, we're just taking the basic square root of a negative 1, which is an imaginary, and multiplying them together. So if I had an x minus I and an x plus I, when I FOIL that out, I get an x squared plus a 1. Okay, so when I multiply this in, and it takes a little work, but I'm going to multiply this in. And now I'm going to combine my like terms. But when I get done with this, x to the fourth, 14x cubed, I've got a couple of x squareds there. Here's my quartic that I was looking for. It's got those two real answers, and it's got a couple of imaginary answers. This is the key right here. This is what you need to multiply in to get those two non-real answers and to get to that quartic. Okay, so let's look at one more. I'll walk you through this one more time. They're looking for a quartic. These are the two answers they gave you. Those are the two real answers. So I know I have x plus 4, x plus 6. So when I multiply that out, do my simplifying, this is where I land. I have to have two more to get to a quartic. So that means I need a couple of imaginary ones. I said this is the key. Multiply that in. You get two more answers. They're imaginary. Still have some FOIL or box method to do here. But when I get done with this, I better slow down. I get 10x cubed, I get a 24x squared, I get an x squared, a 10x, and a 24. And I just combine like terms. X to the fourth, there's my quartic. And there I have something that has four answers, two real, -4 and -6, two imaginary, that comes from right here. Are those the only ones? Of course not. But this is the easiest way to get in two more of those answers.